Hey y'all, I'm Mickey Gousset, and welcome to part 2 of my Introduction to GitHub Actions video series. Now in part 1, and I'll provide a link somewhere around me to part 1, or at least in the description below, we talked about what GitHub Actions was, and we looked at a very simple workflow, the simplest GitHub Actions workflow you could have, which contained one job and one step. So now we want to build off of that, because usually in a workflow file, you may have multiple jobs. So if you have multiple jobs in a workflow file, the question becomes, what order do those jobs run in, and can you control that order? Well, by default, if you have multiple jobs in a workflow file and you have enough runners, those jobs will all run in parallel. However, and if you don't have enough runners, then it will queue up one of the as many jobs as it has runners for, and then the other job and run those, and the other jobs will queue up and wait until a runner is available for those jobs, and then those jobs will run. But if you have enough runners, so for example, let's say you're using hosted runners, by default, all the jobs are going to run at the same time. However, you can control the order that those jobs are going to run in. So we're going to look at an example where we're going to control the order the jobs run in, and we're also going to show you how to use conditional statements to control whether a job even runs. So let's jump over and see how that works. So I'll remind you, we are in my DevOps Elvis organization. I'll let you figure out if you can understand why I called it DevOps Elvis. And the repository is the My GitHub Actions presentation repository. This is a public repository. So you have access to all of these demos. This is the repository where I'll be adding more demos as I go along in this video series and future demo series. So you're welcome to fork the repository. You're welcome to contribute back to it. I would love any suggestions you might have. Now in this repository, if we go to the GitHub Workflows folder, this is where all of your GitHub Actions workflows need to be stored in this folder. And in the first video, we looked at this basic-workflow YAML file. So for this video, we're going to look at the chaining jobs YAML file. So let's break this down. What is this file doing? This file has 4 jobs in it. But first off, we need to give this file a display name. So we're going to call it chaining jobs. And then using the on keyword, we need to specify the event or events that are going to trigger this workflow to run. Because remember, a workflow can be triggered off of multiple different events if you want to. In this case, I'm triggering off of only one event, workflow_dispatch, which is what allows us to manually run this workflow. And because we are using workflow dispatch, we can also provide inputs if we want to. So in this case, I'm providing an input. That input is run-job-3. So we are going to decide, do we want job 3 to run or not? And we're making it a Boolean, so it becomes a checkbox where we're going to check yes or no. Do we want this job to run? After that, we get to where we've defined our different jobs. Now I have 4 jobs defined in this repository. By default, if I didn't include any kind of code to help control the order the jobs run in, all 4 jobs would run in parallel, or they would try to if there were enough runners. But we've made a couple of changes to this, so let's go check this out. So for the first job, we have the jobs section here, jobs. We called it job-1. We give it a display name. The runs on command, as you'll remember, specifies the runner we're going to use. In this case, we're saying use a hosted Linux runner, Ubuntu-latest. We could also use labels for our self-hosted runners if we wanted to say target a self-hosted runner or a hosted Windows runner. In this case, I'm saying use a Linux runner. And then this job has a steps section with 1 step in it. And that step has a display name of output for job 1. And then it's just doing a run command, which we learned about in the previous video, just executes commands in the shell of the runner, in this case bash. And I'm just echoing out hello from job 1. And then I'm echoing out the value that was entered as a parameter. And to access that value, we say $ curly brace, GitHub, we access the GitHub context object, .event, .inputs, and then the input name, which was run-job-3, and then curly brace. So that allows me to output true or false, which is going to be whether I checked the box or not. Then you'll notice we have job 2. Job 2 has a display name of job 2. It runs on Ubuntu latest. But then now we're using a specific keyword, and that specific keyword is needs. So the needs keyword is what allows you to control the order that jobs are going to run in. So in this case, by saying needs and then saying -job-1, which ties back into this value here, we're basically saying job 2 needs job 1 to complete successfully before it runs. So what should happen here is job 1 should run, job 2 should be in a wait state until job 1 finishes, then job 2 is going to run. Also notice that even though we're specifying Ubuntu latest for both of these jobs, these are actually going to be 2 different runners. So job 1 is going to request a hosted runner. So GitHub's going to spin up a hosted runner, give it to you. Job 1's going to execute, then it's going to throw that hosted runner away. Then job 2, when it runs, is going to get a brand new runner. It's going to execute and then throw that brand new runner away. So if you have things that need to be passed from job to job, especially files, you're going to have to figure out a way to do that. And you're going to learn how to do that later on in this video series. But for now, job 2 will execute after job 1 finishes, and we have one step where we're just saying hello from job 2. Now, if we come down and look at job 3, we give it a display name. Here's the ID of job 3. You'll notice that job 3 also needs job 1 to complete successfully. So what we're doing here is we're saying job 1 is going to execute, jobs 2 and 3 are going to wait till job 1 finishes, and then jobs 2 and 3 are going to run in parallel because they will both execute if job 1 finishes successfully. Job 3 also runs on Ubuntu latest. But remember, we are also allowing the person running the workflow to decide, do we want to execute job 3? So to control that, we specify an if statement. So we say if, and then we say go to the GitHub context object, go to the event, go to the input, get the input run-job-3, and if that input equals true, meaning you check the box, this job will run. If that input equals false, then it will skip this job. There's a lot of other things you can do with conditional statements. This is a very simple if statement, but it shows you how you can control whether a job runs. And you can also add if statements to steps as well, if you wanted to control specific steps. But in this case, we're controlling that the job's only going to run if we checked the box on that input value. And you can see that the step just outputs hello from job 3. And then finally, we have job 4. Job 4 has a display name. Job 4 runs on Ubuntu latest. Job 4 needs 2 and 3 to complete successfully. So when we run this workflow, job 1 should run, then jobs 2 and 3 should run, then we want job 4 to run. Now, we've got a statement commented out here. You add comments by using a £. We've got this statement, this if statement commented out here. You'll see why in just a moment. And then this job, the steps, the one step echo hello from job 4. So if we go run this job, so let's go back up to Actions, and I select Chaining Jobs, Then I could come over here to the workflow button. I could run on a different branch. And let's run this the first time by saying we want job 3 to execute. And we're going to say run workflow. Again, in just a moment, it'll pop up here showing you that the job is started, or you could just click the workflow again over here and it shows you. And now you'll notice in the visualization, we actually get a visualization that shows us the order the jobs are going to run in. Job 1 executed. Now jobs 2 and 3 are executing. And now job 4 is executing. And remember, job 3 executed because we specified in that if statement that the job should run. So therefore, we got the output. And you can see that all 4 jobs ran. And in the summary, we can see the order that the jobs are running in. Okay, that's great. So let's go back over to Actions. Let's select chaining jobs again. And this time, we're not going to check job 3. And let's click Run Workflow. So now if we go back to our chaining jobs and we watch this run, we can see again, visualization is the same. Job 1, and then 2 and 3, and then 4. But now you'll notice job 3 shows as skipped. So it didn't fail because we didn't make it fail. We just said skip that job because we didn't check that box. But look at what happened to job 4. Job 4 also skipped. And that's because job 2 completed successfully, but job 3 did not complete successfully and it didn't fail, it just skipped. So therefore, job 4 gets skipped. Job 4 doesn't fail, it just skips. So let's try a couple of other scenarios. What if we want job 4 to run regardless of whether 2 or 3 pass successfully or not? Well, we could go back to our code and we'll go back to our workflow file. And let's edit this file and let's scroll down. And what we'll do is we're going to say that we always want job 4 to run. So that means that whether we skip job 3 or not, job 4 should always run. So let's save our changes. And we're going to live recklessly in job 4 always runs. We're going to commit directly to main because we can. And we'll go back up here to Actions. And we'll go to chaining jobs. And we'll run this workflow. We're not going to check job 3. So now when we run this workflow, now what we should see happen is job 1 should run, 2 should run, 3 should skip, and 4 should run. So 1 ran, 3 skipped, 2 is about to kick off, and then 4 should run. All right. Now, the catch with using that if always statement is we're saying that that job should run, that job 4 should always run, whether even if one of these jobs fails. So if we go back to code, and we go back to GitHub, and we go to workflows, and we go to chaining jobs, and we go to edit this. Let's go down to job 2, and let's add one more step to job 2. And we're going to call this make job 2 fail. And we're going to make it fail by just doing an exit 1. Any non-zero exit code can make it fail. Now we're not going to change anything else. We're going to leave job 4 as still with an if always. And we're going to commit this change, making job 2 fail. Directly to master because we're rebels. We'll go back to Actions. We'll go to chaining jobs. and we'll run this workflow again. So now, again, same thing's still going to happen. We have job 1 that runs. Then when job 1 finishes, job 2 is going to run. Job 3 is going to skip. And then job 4, because we said if always, job 4 should still run. And we can see that job 4 would still run. Now you can see, though, that this time the workflow failed, didn't pass, because one of the jobs failed. And that's how we have it configured right now. If one of the jobs fails, the workflow fails. So what do you think is going to happen with job 4 if we get rid of the if always? Job 2 is going to fail. Job 3 is going to skip. Will job 4 skip or will job 4 fail? Lock in your answer now and let's go make the change. So we'll go back to code. We'll go to GitHub. We'll go to workflows. We'll go to chaining jobs. And we're going to go down to job 4. And we're going to comment out the if always. So when we did this before and job 2 was passing, then job 4 just skipped. Comment out always on job 4. Commit that change. We'll go back up to actions. We'll select chaining jobs one final time. We're not going to execute job 3, which is going to run this, because we've already proven that if one job fails, the whole workflow will fail. But now what's going to happen? Because job 2 is going to fail, job 3 is going to skip, but job 4 no longer says if always. So do you think job 4 is going to run, or do you think it's going to not run? There you go. So the failure of job 2 did not cause job 4 to fail. It still skipped because 3 skipped. So let's do one final change. We'll go to GitHub. We'll go to workflows. We'll go to chaining jobs. And let's come down here and we don't have to make a change. We'll just go to actions. We'll execute chaining jobs, but this time we'll run job 3. So now by running job 3, job 1's going to run, jobs 2 and 3 are going to run. 2's going to fail, 3's going to pass. So what do you think is going to happen to job 4? Let's see what happens. Job 2, job 4 still skipped. And if we look at the workflow file, it still skipped because it needed 2 and 3 to pass. So it didn't matter that 3 failed, 2 failing didn't make job 4 failed. It just meant that if this need statement is not true, the whole job gets skipped. It doesn't get failed. So you need to understand when you're working with jobs, right? When you're working with these things, you need to understand the interaction there. Because otherwise, you may think it's going to work one way. Like you may have thought job 4 was going to fail because 2 failed. But that's not the case. 4 just skipped because the needs statement wasn't true. All right, so that we've shown you how you can organize the order your jobs run in. We've shown you how you can use conditional statements to control when a job runs or doesn't run. You can also use those conditional statements on a step. We've shown you even how you can always make sure a job runs, and we've shown you how to fail a job, which is really helpful when you're trying to do testing. So next video, I'm going to show you how to deal with variables and pass information between steps and between jobs. And I'm also going to show you how to access that GitHub context object in more detail and how to actually see what's inside that GitHub context object. Thanks for watching.